Shah from IT/ICT Department of LG Institute of Engineering and Technology. In today's session, we will be continuing with unit number 9, that is spread spectrum communication, and we will be discussing more about the overall trends in the spread spectrum communication domain. What are the overall trends? What are the code division multiple access techniques that we will be seeing in this session? In the previous session, we have already learned what is spread spectrum communication, how both the communication topics are related, and how the two different types of spread spectrum communication, that is FHSS and DSSS, frequency hopping spread spectrum and direct sequence spread spectrum, are used in this domain, that is spread spectrum communication. So let's understand the topics which we are going to cover in today's session. So following are the topics which we will be discussing, that is introduction, spread spectrum methods, technologies which are related to CDMA, performance analysis of IEEE 802.11 protocol, that is nothing but Wi-Fi, and major development in CDMA domain. So these are the topics which we are going to cover in today's session. So basically, now we are going to discuss introduction to code division multiple access. That is nothing but CDMA technique. Now what is this technique, why it is used widely, and why we are considering it in the domain of spread spectrum technique, that we will be learning from now. So code division multiple access is a fixed assignment access technique that uses spread spectrum and a special kind of coding scheme to allow the transmitters to share the media at the same time. Now, why it is considered as a form of spread spectrum technique? It is considered as a form of spread spectrum technique because the modulated coded signal has higher bandwidth compared to the data that is to be transmitted. So these are the advantages of CDMA technique. Now, how does it support more than one group in the same channel? It allows multiple groups to share the same channel at the same time by assigning each group to different port. So the thing which they have taken over here is an advantage for CDMA is if you have multiple signals allotted with single channel, then every signal will be allotted a different code and they will be working in that code sequence only. So that is the advantage of this CDMA technique. CDMA modulation steps involves generating a local pseudo-random code with higher rate compared to the data that is to be transmitted. XOR the data which you need to transmit with the generated code. So these are the steps if you want to generate a CDMA output. So this is your data signal and this is your pseudo-random code. Now the second step was you need to perform XORing of the pseudo-random code and your data signal so that you can achieve the transmitted signal. So this is your transmitted signal. This you need to transmit for further transmission module. So firstly we will take input data signal, then we need to generate pseudo-random code, and then finally we need to perform XORing of data signal and pseudo-random signal to have our transmitted signal. So this is the block diagram of code division multiple access technique, which is having some general model of spread spectrum digital communication system. So basically you will have an input data into channel encoder. Encoder is going to generate the encoded output. It will further process to the modulator circuitry. In modulator, you will have mixing of the input and the pseudo-random noise generator sequence, and further the output of the modulator will be processed to the channel section. Channel section will further process it to the modulator section. The modulator section will have an input from pseudo-noise generator, and finally the output will be present in the channel decoder circuitry. So this will be the output data signal which is generated using the code division multiple access technique. Now, few questions might be arising in your mind, like what can we gain from the spreading of spectrum? So the thing over here is the immunity from various types of noise is achieved whenever we are performing spreading of spectrum. The another thing is the immunity from the multi-path distortion. See, all these factors are very important whenever we are discussing any noise-free communication system. In this, if you want to avoid all these things, if you want a successful error-free transmission, then you need to focus on such technique which have the removal of following different types of noises. Thirdly, it can be used as an encrypting technique. Several users can use the same channel with little interference. So these are the following advantages which we can have if we want to use the spreading of spectrum. Introducing with this, we need to generate a pseudo-random code. Then how we will be generating it? So the base station generates a unique pseudo-random code for every connection, and these codes should have the following properties. It should be deterministic. Deterministic means it should have some mathematical formulation based on which some random sequence is generated. Secondly, it must appear random to a listener who does not have a prior knowledge about the code. So our code will remain safe, it will remain secure, no one can hack that. So it should appear as a random code to the listener. Thirdly, the cross correlation between any two code must be very small. If the cross correlation is high, then there are higher chances of interference. The code should have a long period. Why it should have a long period? If you have a code having short period, anyone can detect what is the next upcoming code. So that's why the period of your code must be longer. Then another property is related to code correlation. In this code correlation, every user uses different code to modulate his signal. The best performance will be when user signal are separated as much as possible. The separation can be done by correlating the received signal with the local generated code. If the correlation is high, then we exclude this code and we search for another code with less correlation. So following are the properties which we need to take care whenever we are using this coded spectrum communication, and these properties have to be satisfiable, then and only then we will be able to achieve a successful transmission of signal. Nextly, the correlation function has two properties. Either your correlation function can be cross correlation or it can be autocorrelation. So the definition of cross correlation says that the correlation of two different codes used to separate the transmitter signal from each other. So this is known as cross correlation. And what is autocorrelation? The correlation of a same code with a time delayed version of itself used to reject multi-path interference. That is known as autocorrelation. Cross correlation is between two different signals and autocorrelation is between two same signals. So that is the difference why we are performing cross correlation and autocorrelation of signals. Now, the spread spectrum methods include DSSS, that is Direct Sequence Spread Spectrum. In DSSS, every bit from the data which we need to send is represented by multiple bits in the transmitted data, and it is represented using spreading code. The original data is spread out across a wider frequency band by using the spreading code. The spreading proportion depends on the number of the bits used in the code. So this is basically the example of direct sequence spread spectrum. You will have one original data, you will have pseudo-random bit, and based on these two signals, you will have transmitted output over a specific time interval. Next is another kind of technique in spread spectrum method is frequency hopping. In frequency hopping spread spectrum FHSS, at the transmitter end, the original signal is broadcasted over a series of radio frequencies hopping from different frequencies in a fixed pattern. The receiver should use the same hopping pattern simultaneously with the transmitter in order to receive the data originally correct. The spreaded code specifies the sequence of channels, and the receiver should use the same code to tune into the sequence of channels that are used by the sender. So following are the properties for FHSS. The third type or the example of frequency hopping spread spectrum includes code division multiple access. This is how the channel can be used multiply. So the other kind of technique in spread spectrum method is chip spread spectrum, CSSS. It is the first and simplest application of multidimensional multiple access technology, that is MDM. At a time, multiple channels you can access and multiple signals you can transmit. It encodes the information by using wideband linear frequency modulated chip. It uses the entire allocated bandwidth to broadcast the signal, which helps making it robust to channel noise. Also, it is immunized from the multi-path pairing because it utilizes the whole spectrum broadband. It finds the noise by relying on the linear nature of the chip pulse. So this is about CSS. The next kind of spread spectrum method is time hope spread spectrum, that is THSS. The period and duty cycle of a pulse radio frequency carrier are varied pseudo-randomly under the control of coded sequence that is similar to FHSS. It consumes low power due to the very low duty cycles. In THSS, the pseudo-random number determines the sequence of how the burst will be transmitted. So basically this is the waveform of code division multiple access in which you can see the transmitted line slot have been allocated to a specific code phrase. Now the technologies which are based on CDMA includes Wi-Fi, it includes code division multiple access. So let's understand what is the technology which they are preferring in this Wi-Fi communication. Basically in Wi-Fi IEEE 802.11, the two standards are involved, that is 802.11b and 802.11g. Both are working in a 2.4 frequency band because this is allocated by the ISM standard. ISM stands for Industry, Science and Medicine band. This band is fixed by ISM standard, that is 2.4 frequency band should be allocated to Wi-Fi ranges. DSSS and FHSS physical layer options have been designed specifically to overcome the interfering with other devices in this manner. So these concepts are used for Wi-Fi technology also. This is the allocation or the three non-overlapping DSSS channels in the ISM band. First channel is allocated at frequency 2.4120. Channel 6 is allocated at 2.4370 and channel 11 is allocated at 2.4620. So the frequency allocation starts from 2.4 GHz band for various applications based on green, red and yellow portion shaded based on the frequency allocated by ISM band. So following are the references for the topics which we have covered today. In the next session, we will be learning more about the technologies which are related to the spreaded communication. Thank you for watching this session. Thank you so much.